9.5, number 33, finding the interval of convergence. Find where it converges absolutely, find where it converges conditionally. So, ratio test to find our initial interval of convergence. So I get over n plus 1 square root of n plus 1, 3 to the n plus 1 times the reciprocal, so it would be n square root of n, 3 to the n over x to the n. Alright, so our n stuff and our x stuff. I have one more x on top, so already I know that that's the case, because we're doing the absolute value of everything. Then the n stuff, let's see, I've got one more 3 on the bottom than that, so I know that that's going to be 1/3. And then I've got n square root of n over n plus 1 square root of n plus 1. We have to find the limit as n goes to infinity of that. So it's n to the 3/2 on top. So if you multiply, so that's n plus 1, that's to the first, that's n plus 1 to the half, so it's n plus 1 to the 3/2. They have the same exponent, so you can consider it n over n plus 1 to the 3/2. And as n goes to infinity, this becomes 1, and 1 to the 3/2 is just 1. So this whole thing goes to 1, which it often does. So I have 1/3 absolute value of x has to be less than 1 to find our interval of convergence. I'm going to multiply by 3. Okay, so x has to be less than 3, or the opposite of x has to be less than 3. Divide by -1, so x is greater than -3, and x is less than 3. So our interval of convergence initially is -3 to 3. Alright, so now we have to check at x equals -3 and x equals 3. See what happens. See if it converges on the endpoints. So at x equals -3, this is what it looks like. So -3 to the n over 3 to the n, you could think of that as -1 to the n. And since I have, well, let's try, since it alternates, we could say, yes, it alternates. The limit as n goes to infinity does equal 0, and each successive term does get smaller as n increases. So this would converge. We could use alternate series test. So we know that we include -3 on our interval. So our upgraded interval of convergence is -3 to 3, and we have to figure out if we're going to include 3 in our interval. So it's 3 to the n over n to the you get when you plug 3 in for x. So that's 1 over n to the 3/2, and we don't even have to compare it to anything. It's literally, since p is 3/2 and 3/2 is greater than 1, we'd say that this converges. I would just say p equal to 3/2. So we do include 3 in our interval also. Alright, so in our interval of convergence, -3 to 3. So what about these endpoints? Do they converge conditionally? Well, we know that this one converges. Does it converge? Absolutely. So if we make this positive, it just becomes this one over here. So it will converge absolutely and regular. So it doesn't change. It's not converging conditionally. If it converged regular but didn't converge absolutely, then it would be conditionally convergent at -3. Plugging in 3, okay, we know it converges. If we change it to absolute value, it doesn't change a thing, so it still converges. So there are no points where it's going to converge conditionally. So where does it converge? It converges -3 to 3 inclusive. Where does it converge absolutely? It converges the same interval, -3 to 3, including both endpoints, and it does not converge conditionally anywhere.